The poles and cross arms have been distributed along this section of an open wire line, and the holes have been dug for the poles and any required guys. Now you can equip and erect the poles. This pole is to have 2 single cross arms. These cross arms will be attached before the pole is erected. For through bolts, use 5/8 inch machine bolts. Place a square washer on each bolt and insert each into the hole from the back of the pole. The through bolts must be long enough to extend about 5 inches beyond the face of the gain. Then turn the pole over so the face is up. Now you are ready for the cross arms. The cross arm is placed over the bolt with the braces away from the pole. Place a square washer over the bolt and tighten. After placing a square washer over the bolt of the second cross arm, the nut is tightened. The next step is to line up the cross arms so that they are at right angles to the axis of the pole. Use a string stretched from the pole center line at the bottom of the pole to the through bolt on the lowest cross arm as a guide. Then place a steel square against the lower cross arm and line up the square with the string. After the cross arm is aligned, tighten the nut firmly. The lower ends of the cross arm braces have been brought together so that the holes overlap. A 4.5 inch lag screw is used to fix the braces to the pole. Once the lower cross arm is in position, the other cross arm is lined up parallel to the first, using the square. After lineup, you tighten the nut of the through bolt for the top cross arm and fix its braces to the pole in a similar manner. The next step is to erect the pole. Poles may be set either with the pole derrick or with pike poles. Here, a V-17 truck with a derrick is being guided to a position which will center the tip of the A-frame over the hole. The truck is stopped when the top of the A-frame is centered directly over the hole. Then the winch line is brought to the position where it will be attached to the pole. This position must be just above the balance point so that the butt of the pole will stay down when the pole is lifted. Pass the free end of the winch line under and around the pole. Make sure that the open end of the S-hook faces the butt or bottom of the pole. This is a must safety measure because the running end of the winch line will pull against the top and back of the hook, and thus ensure that the winch line will not slip out of the S-hook while raising the pole. On receipt of the signal, the winch is engaged to raise the pole. As the pole is raised slowly, one man guides the butt until it is centered above the hole. Another man carefully watches the raising operation and gives the required hand signals to the winch operator. He must carefully watch the raising operation to make sure that the S-hook never comes nearer than 1 foot to the sheave as it approaches the top of the boom. If necessary, move the truck to pull the pole into position rather than foul the S-hook. Slack off on the winch line to lower the pole into the hole. When the pole is resting on the bottom of the hole, you can use a cat hook to face the pole in the proper direction. After facing the pole in the proper direction, the winch line can be removed and the pole is ready for aligning and tamping. Poles are faced so that any pull from the wires will pull the cross arm against the pole. Along straight sections of line, the facing of the poles alternate. each pole being faced opposite to the next one. Then half the poles will be faced correctly for any pull in one direction, the other half for any pull in the other direction. When you have a longer span than usual, you face the poles at each end of the long span away from each other. Longer spans create a greater weight between the poles. This results in a pull toward the center of the span. When you have a steep grade, you face all of the poles uphill because the pull of the wires is downhill. The pole next to a dead end is faced toward it to take the pull from the line. Usually the poles next to a corner pole face toward the corner. However, if there is a long span on one side of the corner, the pole will face away from the corner. When poles face a single corner pole, the pull from the line on each side will tend to pull the cross arms toward the poles. The facing of the poles on either side of a two-pole corner is also toward the corner poles to take care of the pull along the line. The corner poles themselves face each other because the pull of the lines from the corner pole to the next pole is greater than the pull between the two corner poles. After being set and faced, the pole must be placed in a true vertical position before the hole around the pole is filled with earth. Normally, 4 men using pike poles are used to straighten the pole. To position the pole in its true vertical position, 1 man, from a short distance away, sights in the pole from the side. Another man sights in the pole from the line of lead. The pike poles are braced to the ground, keeping the pole in its true vertical position. The next step is to backfill the hole around the pole. As a safety measure, all 4 of the braced pike poles should be held in position. This will keep the pole straight during the backfilling of the hole. It is important that the earth be tamped thoroughly, the full depth of the hole. If possible, use coarse soil or gravel for filling in the top of the hole. Bank the earth around the pole above ground level and pack it firmly. This will permit rain to run off away from the base of the pole. Where it is impossible to get a truck with a derrick into a position where a pole is to be raised, it will be necessary to erect the pole manually. When a pole must be erected manually, it is easier to raise it without the cross arms being attached. Here, the hole for the pole has already been dug to the proper depth, and the men are about to raise the pole. To prevent the butt of the pole from gouging the hole, place a butting board on the side of the hole away from where the pole lays. In firm soil, you can use digging bars instead for this purpose. Then bring the butt end of the pole to a position in line with the butting board and slide it against the butting board. Next, you can begin raising the pole from the top end. For a heavy pole, such as this one, use a pole support, commonly referred to as a dead man, to hold the weight of the pole while the men shift their position to continue the raising operation. Use the dead man whenever necessary to support the pole. After the pole is partially raised, you can use pike poles to advantage to complete the raising operation. The two men on the side use the pike poles to guide and push. The two center men use the pike poles to push the pole upward. Pike poles must be held securely so they won't slip and injure another lineman. Shift the pikes one at a time to a new position. Then raise the pole again. When the pole is past the 45-degree angle, you can work to better advantage if you use one hand to support the butt of the pike and the other hand to guide it. Once the pole is erected, it is faced in the proper direction. In this case, since the cross arms have not been attached, the gains on the pole are used as a guide. Now the pole is ready for aligning, then backfilling and tamping. After the pole has been firmly fixed in position by backfilling and tamping around the base of the pole, you can attach the cross arms. A sheave block has already been lashed above the top gain of the pole and a hand line fed through it. Pass the loop of the hand line around the cross arm and over one of the pins. Then at the end of the cross arm, use a half hitch. Other tying methods, which will permit the man at the top of the pole to easily remove the hand line, may also be used. Now you can lift the cross arm. Where short poles are used, the sheave block may not be necessary. This single cross arm is attached as usual with a 5/8" machine bolt. To level the cross arm, a man sights it in from the ground. After leveling the cross arm, tighten it firmly in position. Then the cross arm braces are attached to the pole using a lag screw. Sometimes an 18-inch spacing between cross arms will be specified. The holes drilled by the manufacturer on the cross arms cannot be used for the braces for 18-inch spaced cross arms. Instead, additional holes 4 inches farther out are drilled and used. You may also have to build a line where 12-inch spacing between cross arms is specified. Here, you move the braces to the back side of the cross arm. The double cross arm, that is, a cross arm on the face and back of the pole, bolted to each other, is used to support a strong pull from one direction. Here we see two double cross arms on a pole. This construction may be used for a dead-end pole or a corner pole. To construct a double cross arm, bore bolt holes 10 inches from each end of each cross arm. Make sure you keep the brace straight when you drill the holes. When the holes are completed, the cross arms are ready for the installation of bolts, which will hold the two cross arms together. B-bolts, equipped with square washers, are installed in both ends of one cross arm. Then the B-bolts on the ends of this cross arm are tightened. Now you are ready to attach the cross arm, which has been equipped with B-bolts, to the pole. Feed another B-bolt equipped with flat washer and nut on one end through the cross arm. Then use the B-bolt as the through bolt and feed it through the hole in the pole. Now you can place the other cross arm on the other side of the pole, passing the bolts through the prepared holes. Although cross arms are attached to both sides of the pole, a gain has been cut on only one side to avoid weakening the pole. A square washer and nut are placed on the other end of the through bolt, which holds the cross arms to the pole, and on the B-bolts at the ends of the cross arms. Next, measure the distance between the cross arms at the pole. Then make the distance between the ends of the cross arms the same as it is at the pole. You adjust this distance by turning the nuts on the B-bolts. The cross arms are made level, as in the usual cross arm installation. Then, the braces of each cross arm are attached to the pole with a lag screw. When completed and in position, the double cross arm construction looks like this. Two 30-inch braces are attached to each side of the pole. To reinforce cross arms on corner poles where the pull is not too great, you can use a back brace instead of a double cross arm. After the back brace and the cross arm are attached to the pole, line up the back brace along the center of the cross arm. Then, using the holes in the back brace as guides, bore holes in the cross arm. Now you can bolt the end of the brace to the cross arm. You do the same at the other end of the brace. After you level the cross arm in the usual manner, attach the 30-inch braces. The pole may now be erected. Here is a 2 cross arm pole set in position. Notice that it has both back bracing and vertical bracing. Where more than one cross arm using back bracing is placed on a pole, install vertical braces between the cross arms. The vertical brace is attached to the side opposite the back brace. Notice that the inner bolts of the back braces are used to fix the vertical brace in position. Another similar type of installation is this side arm construction, which is used when a building or other obstacle prevents standard construction. For this side arm construction, a 5.5-foot back brace is used on the long side of each cross arm. Whenever 2 or more cross arms are used for a side arm construction, a vertical brace must be attached to the other side of the cross arm. In the side arm construction, a diagonal brace is used to support the off-center cross arms. This diagonal brace has a footrest for use by linemen stringing wire on the pole. The lag screw holding the diagonal brace to the pole is 2 inches longer than normal for additional strength. In constructing a side arm installation, you will have to bore additional holes in the cross arms and move the pins to meet the particular situation. On the top of this pole, a buck cross arm is being used to turn a corner. It is used less often now for turning corners because the sharp bend in the wires gives excessive loss in high-frequency carrier circuits. Instead, a two-pole corner is used now for turning corners. Construction of a buck crossarm is not as complicated as it appears. The top double crossarm is attached before the pole is erected. The second double crossarm is attached after the pole is erected and is placed at right angles to the first. Because the braces of the upper double crossarm would interfere with the installation of the lower double crossarm, they are not attached to the pole until after the lower double crossarm has been installed. After tightening the nut of the through bolt for the lower double crossarm, the ends of the lower double crossarms are bolted together. You can use a standard B-bolt, as is being done here, or you can use a wooden separating block and a machine bolt. Once this step is completed, the crossarms will be leveled and the braces attached to the pole. For long span construction, the H fixture is often used because of its great strength. Two poles are used to support the double crossarms. In erecting an H fixture, each stage of construction must be done carefully to make the structure fit together properly. Holes for the poles must be 6 feet 8 inches between centers. Poles must be the same class, and crossarm holes on the poles must be level with each other. Holes for the poles will be the same depth on level ground. On level ground, the two poles of an H fixture will be the same height. In every case, holes for the through bolts for attaching the crossarms to the two poles must be level with each other, and only one of the two poles is gained. If the holes of the first top crossarm do not exactly line up with the top holes on each pole, the horizontal distance between the two poles can be adjusted slightly in either direction for perfect alignment. Holes for the through bolts for an H fixture are bored 18 inches in from each end of the crossarms to accommodate B bolts. Two lengths of crossarm braces are used: a 20-inch brace near the end of the crossarm and a standard 30-inch brace toward the center of the crossarm. H fixtures often have several crossarms. The additional crossarms are installed in the same way as the first one. You have seen many of the usual methods of erecting poles and attaching crossarms. Normally, you will use single crossarm construction. For additional strength, the double crossarm may be used for a dead-end pole or a corner pole. Or for additional strength for a corner that has a slight pull, a back brace is used. To bypass an obstruction such as a building, the sidearm construction is used. And for long spans and for stability of the line, the H fixture is used. By selecting the most suitable type of crossarm construction, you can safely support any communication circuits. lowest crossarm as a guide. Then place a steel square against the lower crossarm and line up the square with the string. After the crossarm is aligned, tighten the nut firmly. The poles and crossarms have been distributed along this section of an open wire line, and the holes have been dug for the poles and any required guys. Now you can equip and erect the poles. This pole is to have 2 single crossarms. These crossarms will be attached before the pole is erected. For through bolts, use 5/8 inch machine bolts. Place a square washer on each bolt and insert each into the hole from the back of the pole. The through bolts must be long enough to extend about 5 inches beyond the face of the gain. Then turn the pole over so the face is up. Now you are ready for the crossarms. The crossarm is placed over the bolt with the braces away from the pole. Place a square washer over the bolt and tighten. After placing a square washer over the bolt of the second crossarm, the nut is tightened. The next step is to line up the crossarms so that they are at right angles to the axis of the pole. Use a string stretched from the pole center line at the bottom of the pole to the through bolt on the lower